In this session, let us see what are coordination compounds, what are ligands, how they are classified, and chelating ligands, nomenclature of coordination compounds. So what are coordination compounds? So compounds formed by the combination of two or more simple compounds which retain their identity in the solid state as well as in dissolved state. So example for coordination compounds are complex potassium ferrocyanide cuprammonium sulfate. So our coordination compounds are the compounds which contains one complex ion. So complex ion is nothing but electrically charged radical containing a central metal atom or central metal ion to which a number of neutral molecules or ions attached to it. So this is the complex ion carrying negative charge. This is the complex ion carrying positive charge. Here iron is the central metal atom to which 6 cyano groups is attached. In this complex ion, copper is the central metal atom to which 4 ammonia groups is attached. And the charge on the complex ion is the algebraic sum of charges carried by the central ion and the ligands coordinated to it. So in this example, iron is having the charge plus 2, 6 cyano group, each Cn minus, that is 6 minus. So minus 6 plus 2, so algebraic sum will be minus 4. Here copper carries plus 2 charge, ammonia is neutral, so the overall charge will be plus 2. The important term in coordination chemistry is coordination number. So the number of coordinate bonds formed by the ligands with the central metal ion in the complex. So in this example, 4 ammonia molecules will form coordinate bond with the copper. So coordination number of copper is 4. And in this example, coordination number of iron is 6. So the central metal atom or the ligands attached to it enclosed in a square bracket are collectively known as coordination sphere. So in coordination sphere, there will be central metal ion, ligands attached to it, and coordination number written in the square bracket and the charge. Then what are ligands? The important term in the topic, ligands or the ions or molecules which can donate one or more pair of electrons to the central metal ion in the complex. And these ligands donating pair of electron forms coordinate bond with the central metal ion. So the central metal atom will possess vacant orbitals to form coordinate bonds. And the atom in the ligand which donate the electron pair is called donor atom or coordinating atom or ligating atom. Coming to types of ligands, depending upon the number of coordinating donor atoms present in the molecule, they are classified as monodentate ligands, bidentate ligands and polydentate ligands. Ligands which can donate only one pair of electron is monodentate ligand, which can donate two pair of electrons or which possess two donor atoms or bidentate ligand. For examples for monodentate ligand, it may be either neutral molecule or ions. Oxalate anion, ethylene diamine, dimethyl glyoxime are the example for bidentate ligands. So polydentate ligands, that is which coordinate with central ion through more than two donor atoms present in the molecule. Either it may be 3 pair of electrons or 4 or 5 accordingly named as tridentate, tetradentate, pentadentate and hexadentate ligands. So ethylene diamine tetraacetic acid abbreviated as EDTA, is a very good example for hexadentate ligands, which has 6 donor atoms. Ambidentate ligands. So these are ligands which have 2 or more donor atoms. But during the complex formation at a given time, only one donor atom is attached to the central metal ion. For example, nitro group can coordinate through nitrogen or through oxygen. So it is called as nitrito. So NO2 can coordinate through nitrogen or through oxygen. So it's an example for ambidentate ligands. Coming to chelation, which includes chelating ligand and chelates. So here, when a bidentate or a polydentate ligand is attached through 2 or more donor atoms at the same central metal ion forming a ring structure, complex is called a chelate. For example, dimethylglyoxime, ethylene diamine or chelating ligands. If you take ethylene diamine as an example, it has 2 donor nitrogen atoms. So the lone pair on nitrogen can be used to form coordinate bonds. So this will form a ring structure with the central metal ion. So it is example for chelating ligand, and this is the chelate cation formed by ethylene diamine. So these ligands will form ring structure. So coming to the important part, nomenclature of coordination compounds. So before going to the nomenclature, first we have to know how to write the formula for complex compounds. First, central atom is written first, then ligands. Among ligands, anionic ligands are listed first, then followed by neutral ligands. If more than one anionic ligands are there, then alphabetical order is followed. And if more than one neutral ligands are also present, then also alphabetical order will be followed. And if polyatomic ligands are present, they are written in the parenthesis. See the rules for naming the coordination compounds recommended by IUPAC. So first is order of naming ions. In coordination complexes, cation is named first and then the anion. In neutral complexes, a one-word name is given. Second rule is naming the coordination sphere. So in the coordination sphere, ligands are named first and then the central metal ion. The third rule is names of ligands. So in case of negative ligands, the name ends with O, and in case of positive ligands, it ends in IUM. The neutral ligands are named as such. So in this example, the name is given as potassium hexacyanoferrate 2. In this, diamine tetrachloroplatinum 4. These are example for negative ligands. So the name ends with O. Chloro, fluoro, bromo, cyano, acetato, sulfato, oxalato, carbonato, nitrato, hydroxo. For positive ligands, it ends with IUM. For this, nitrosonium, nitronium, hydrazinium. For neutral ligands, the name is kept as ethylene diamine for this pyridine. But for some neutral molecules, the name commonly used as for water molecule aqua, nitrosyl for NH3 amine, CO carbonyl. So the next rule is order of naming the ligands. Ligands are named in the alphabetical order irrespective of their being neutral or negative or positively charged. Fifth rule is numerical prefixes to indicate the number of ligands. If more than one simple ligand of a particular kind is present, That is, if 2-chloro, 2-nitro is present, the prefixes di, tri, tetra, penta are used to indicate their number. Suppose if the ligands have names such as ethylene diamine, triphenylphosphine, ethylene diamine tetrastato, etc., which already contains the affixes di, tri, di, tetra, etc., then their numbers 2, 3, 4, etc. are indicated by prefixes such as bis for 2, tris for 3, tetrak is for 4. And sixth rule is ending of names. When the complex is anionic, then the central metal atom, the name of the central metal atom ends in ATE. For cationic and neutral complexes, the name of the metal is given without any characteristic ending. If it is iron, it is iron, cobalt, cobalt. But for in anionic complexes, for iron, it is written as ferrate. So in this example, it is an anionic complex. So here the name is calcium hexacyanoferrate 2. In this example, it is a cationic complex. The name is hexa aqua iron 2 sulfate. For anionic complexes, usually the Latin names of metals are commonly used, like cuprate for copper, ferrate for iron, argentate for silver, stannate for tin, aurate for gold. And oxidation state of central ion. As in the earlier case, we have written iron 2, ferrate 2, so which indicates oxidation state of the central metal atom. So the oxidation state of central ion is designated by Roman numerals such as 2, 3, 4 in the parenthesis at the end of the name of the complex without any space between the two. So in this example, this complex is named as potassium tetracyanonickelate 2. Here in this, the name is pentacarbonyl iron 0. Its oxidation state. Oxidation state of iron is 0. Here oxidation state of nickel is 2. Here in this example, sodium tetracarbonyl cobaltate minus 1. Its oxidation state is minus 1. So in the next rule, that is of bridging groups, that is for ligands which acts as bridges between two metal atoms, the Greek letter mu is written before their names. So here in this example, two chlorine atoms is bridging between the two metal ions. So since two groups are there, it is di. Since it is a bridging group, mu is written. So di mu chloro. So prefix di mu chloro is written in this example. Suppose if the bridging groups are different or different kind, then prefix mu is written before the name of each kind of bridging ligand. And the next rule, points of attachment. If a ligand has more than one donor atom, then the point of attachment of the ligand is indicated by putting the symbol of atom through which coordination occurs after the name of the ligand. For example, nitro group can coordinate either through nitrogen or through oxygen. So if it is coordinating through nitrogen, it is written as nitrato N. If it is coordinating through oxygen donor atom, so it is written as nitrato O. Similarly, thiocyanate ion can coordinate through sulfur or through nitrogen. So it is written as thiocyanato S. If it is through nitrogen, it is thiocyanato N. So point of attachment, that is atom, is indicated. And in case of naming of geometrical isomers, here in this example, if we see the groups, the ligands are attached or in the same adjacent position, then it is prefixed as cis. In the opposite position, it is prefixed as trans. And in case of optical isomers, the extra or levorotatory of optically active compounds are designated as plus and minus or D and L respectively. And the last rule is abbreviations for complicated molecules. For complicated molecules, abbreviations are generally used. For example, for ethylene diamine, instead of writing ethylene diamine, EN can be used. For pyridine, simply PY is used. For acetyl acetonato, we can abbreviate it as ACAC. So in this example, for ethylene diamine, instead of writing this, simply it can be written as EN twice, ethylene diamine twice. These are the rules it should be followed to give the name for the complex compounds which is recommended by IUPAC. That is, name some complex following the rules. So K3FeCN6, it is a anionic complex. That is, complex will carry negative charge. So cation is potassium. So cation is named first. So potassium hexacyanoferrate 3. So in the second example, it is calcium. Cation is named first. 6 cyano group is there. Since it is a negative ligand, the name is cyano. So calcium hexacyanoferrate 2. So the name of the central metal atom ends with ATE in case of anionic complex. In the third example, since it is a cationic complex, so first cation is named. So tetra for tetraamine copper 2 sulfate. Oxidation state of copper is 2. So in this example, it is hexa aqua. So photomer molecule commonly used as aqua. Hexa aqua chromium 3 chloride. Oxidation state of chromium is 3. So in this example, ethylene diamine. So the name, in the name itself, the number di is there. So it is named as 3 ethylene diamine. So we have to write it as tris ethylene diamine in the bracket cobalt 3 sulfate. So last example, there are 2 ligands within the sphere. So we have to follow the alphabetical order. NH3 amine group. So amine will be named first. So diamine tetrachloroplatinum 4. So in this session we have come across coordination compounds, complex ion, ligands, types of ligands and the nomenclature of coordination compounds. That is, what are the rules to be followed to give the name for coordination compounds. So with this, I will end this session. Thank you.